Hello. Okay, we got 4 people here. Awesome. Oh, 3 people. Come on, let's go. Let's get more people online. Here, I'll change my message. I'm back. So I just had to make myself a coffee. Kind of lost track of time, and I thought, oh, there's no way I can make it through this lesson without a coffee because I need some energy. Got a couple things I want to talk about before we do the lesson. Some housekeeping stuff, that kind of thing. So stay tuned for that. Just wait for a few more people. Let's see if we can get 10 people online. Once we have 10 people, then I'll start talking about some of the administrative stuff, because it is actually quite important that that as many people hear this as possible. While we wait, I'll just tell you something kind of cool. The new how do I get rid of that? The new version of iPad OS allows you to use a mouse. I mean, you could always use a mouse, but it was really finicky and kind of silly. But now I can use a mouse, which is kind of neat. So now I can use this kind of like as a pointer. So I've got an extra mouse just sitting here. So yeah, I'll use that as a little pointing device. Oh, I might. I don't know. I haven't tried it out yet, but because I also have this pointer too, right? Oops, like this thing here, which is useful, and it can also just be a little dot like that. So I don't know. I might just use this as a pointer as well, or instead. I don't know. Okay, we got 9 people. Good morning, everybody. Okay, once we get to 10 people, I'll start telling. Oh, there's 11 people. Okay, great. I wonder if maybe that's just a few people like opening up a new tab and putting the YouTube link in the new tab. I hope not. I hope it is genuinely 11 people. I'm not actually sure how YouTube calculates how many people are actually watching. I mean, how would that count as 2 people if you just opened up a new tab, or do they look at the IP address? Not sure how that works. Anyway, a couple things I want to talk about. So let's make a little list here. So, oops, it's not this. No, I want this. Okay, housekeeping. Okay. If you didn't already know, housekeeping usually just refers to sort of like the sort of not random, but sort of like the kind of topics that like this isn't math. But it is about our class, and so these are some housekeeping items. So the first thing I want to talk about is oh yeah, so attendance. So we'll talk about attendance. After that, I want to talk about a feedback form. So we'll talk about feedback. And I think that was pretty much. Oh yeah, there's a big one. Bonus assignment. And I shouldn't actually really call it a bonus assignment. It's not really bonus. It's more like a retest or a reassignment or whatever you want to call it. Okay, and I think that's pretty much it. So we'll talk about these things, and then we'll jump into math. We're going to talk about radical equations today, and then we'll do some examples, and that'll probably be the whole class. So that's our plan for today. I'm just going to open up a file on my computer before we jump into it, and there we go. Just give me 2 seconds. Here we go. Okay, beautiful. Okay, so attendance. So going forward, starting next week, attendance. Okay, so starting next week, I've been asked to start taking attendance. And the purpose of the attendance is not to like first of all, I'm not going to be like on the live stream calling out your name and expecting you to like reply in the chat or something like that. That's not what it'll look like. The what it'll look like is it'll be some kind of exit slip. Okay, and if you haven't seen exit slips before, what an exit slip is it's kind of like a very, very small assignment, typically 1 or 2 questions. So, like for example, today we're going to do radical equations. I might just make a very simple radical equation saying, okay, the square root of x is 3, solve for x. Okay, that would be one example of an exit slip. It's almost just like a way of making sure that you came to class. The exit slip, it'll just be through some kind of Google form thing on my website, and I'll be using the same Google form for all of the exit slips. Otherwise, it would be kind of a logistical nightmare to have 4 new forms and 4 new spreadsheets to administer. It's going to be one Google form for all of my classes for every single day. The only thing that will change is the question, and the question will be for the exit slip questions. The questions will be in the videos. So I might say something like, okay, so the exit slip today, your question is, and I would just write it down in the video, and I won't tell you the answer, you would just submit the answer. They won't be for marks. It's not for marks, so you're not going to be like improving your grade for for this. I'm not going to be telling you the answers. It's kind of just like a very quick question, and the purpose is just to get some data about how many people are watching the streams. So I've been asked to do this. I forget if it's just a Grant Park thing or if it's a school division thing or even if it's a provincial thing. But I have been asked to start recording attendance. And there's a few things that I think are really important. So this attendance, the way I'm going to record attendance, will not be on your report card. So this is not going to be reported on your report card. Okay? So it's in a lot of ways it's kind of like an unofficial attendance. The purpose is not to like no one is gonna be getting in trouble. No one's gonna be getting a phone call home saying like, oh yeah, your kid is so bad. They skipped class yesterday. That's not the purpose. The purpose is absolutely not to get anyone in trouble or to put pressure on anyone. This hopefully shouldn't really like alter anyone's sort of behavior. The purpose of this is to collect data. I believe that the school division wants to know how many students are partaking in digital classes so that they can make informed decisions about what next year is going to look like. Maybe have some anticipations about what is going to need to be done next year. So there's just a lot that we don't know, but so you can kind of imagine the position that they're in, right? Like nobody knows what the future is going to look like right now. Like we're at kind of a weird place right now. I don't know if school will open again in September. I certainly hope so, but I don't know. And I don't think anyone knows. So you can imagine that if you don't know things like that, then you're going to want to know as much as you can about the things that you can know. So the purpose of the attendance is not to get anyone in trouble. The purpose of the attendance is to see how many of our students right now are actually partaking in online lessons and are continuing their learning. Because certainly it's not 100%. I can tell you that. Like I have the numbers. I can see exactly how many people are watching the video right now, and I know that some people are watching it after the fact. But based on the number of assignments I've been receiving, and it's not just this class; it's all of my classes. Actually, this class is very good. Like this is actually like my top class in terms of how like the proportion of people who are handing in assignments. But a lot of people, and this is not anyone's fault. I'm not saying that these, like, if you're not partaking in class and you're some kind of bad person. It's just that, you know, this is a weird time, and you know, mental health is extremely important, and it's possible that it's just not feasible for some people to keep up with this, and I completely understand that. That said, I'm still doing this, and I really enjoy this, and for me, this is actually, I have to say, like the thing that gives my my day structure, and it gives me something to think about, and it's a challenge, and this is really important to me. But I can also understand if you can't do it, right? And so that may be the case. And the purpose of the attendance is just to check up on who's partaking, and it's not even so much about names; it's more about numbers. So how many people are actually come into class and watching videos, or whatever your other classes look like. How many people are participating in their learning during this isolation period? So that's that's the purpose of the attendance. It's not going to be reported on your report card. It's not about getting people in trouble. It's not about shaming people for not partaking. It's about getting numbers so that come next year we can kind of prepare or be prepared for, you know, X% of students who are missing this portion of their education. Because as teachers, it's really important for us to know where our students are coming from, how can we prepare for certain things. So if we can know that like 30% of our students missed, you know, 3 months of school last year, that's really good information to have, because it helps us prepare for things. And maybe it might even open up opportunities for like some kind of remedial type of classes, you know, like a math help class kind of thing, where it's like, okay, yeah, I wasn't able to complete this portion of last year, but you'll still be pushed on to the next grade, but you'll just get some extra help or something like that. So it's really important for us to get these numbers so that we can get prepared for next year. So that's attendance. Okay, so I've done attendance. Next up is feedback. And this is kind of just a thing between me and you. So this is just a Mr. Bennett thing. So it's going to be a Google form. I'm in the process of making it now, and I want to know how you're doing. I want to know if you have any suggestions for me. I want to know how you're finding the workload. And there's also a little bit about final exams. Ooh, final exams. I bet you were hoping I wouldn't talk about that. So final exams, what are they going to look like? Are we even going to have them? If we do have them, what will they look like? If we don't have them, what will take their place? These are all questions I don't have the answer to. And before I make any big decisions, I'd like to hear from you, because you know, although this is my class, I'm the teacher, and I do decide these things. I'm in charge. I do want to know where my students are coming from, what they want, what they don't want. So let me know. So please take some time to fill out the Google form. I'm hoping to have it on my website by the end of the day. If not, it'll be up by tomorrow. So maybe don't even bother checking today, but just check tomorrow. And it might take a couple minutes to fill out. I've got a lot of questions for you. None of this is going to be used against you. I think I have one question on there asking if you watch the live streams. I'm not going to be using that as like attendance data or anything like that. I just want to know how my students are partaking in their learning, and if they have any suggestions for what I can do to make this experience better for everybody. Okay, so that's the feedback form. So that's on the website. And finally, the assignment. So you may have noticed that on Google Classroom I posted a new assignment. It is on sequences and series. So it was asked by several of my students to redo that assignment, and I think the reason for that is because that assignment occurred right around the time of the progress reports, and the progress reports kind of just made everything very tight because I assigned the assignment, and then there were, the progress reports were coming up the next day, so a lot of people felt pressure to hand in the assignment on time, where they feel like they maybe would have got a better grade if they handed it in late, and there may have been some miscommunications there. So so the assignment, we're going to redo it. So the way it'll work is that you don't have to do the assignment if you don't want to. It's optional. But if you feel like you could do better, then go ahead with it. However, I'm not like, if you decide to do it, I'm going to mark it, and that will be your new mark. So let's say you got like 80% on the first assignment, and on this assignment you got 70%. Your new mark will be 70%. I'm not gonna play a game where I'm just gonna give you like the highest mark. So if you want to replace your old grade with something that you feel like you're better off, so if you think you can increase your grade, then you can do so with that assignment. Now that said, I'm still going to be following the guidelines for the school division to use your mark for March 20th as the lowest possible grade. But even so, like, I'm still going to replace your grade with that. So, I guess it's kind of hard to explain, but what I'm trying to say is that if you feel like you did okay on that assignment, don't do that. Don't do the makeup assignment. It's just going to be extra work for you. The due date is tomorrow at midnight, so you don't have a lot of time to do it. I really just want this assignment to be for just a few students who felt like they didn't have the opportunity that they were owed to do that assignment well. If you just want to sort of improve your grade because like you got because you want a better grade, I wouldn't suggest doing this assignment. It's hard. It's not an easy assignment, and I don't want that to bring your grade down, right? Because I'm just going to be replacing the grade that you get on this assignment with this new assignment grade. So only do this assignment if you like either like did really poorly on that first assignment, or if you think that you just didn't have a good chance to really show me everything that you know about sequences and series. Okay? Okay, so that's the housekeeping for today. So yeah, just keep in mind starting next week, we'll be having attendance in the form of an exit slip. Our feedback form will be up later today, so check it tomorrow and give me some meaningful feedback about these classes and any suggestions you might have for how we could do better. And there's an assignment, and only do this assignment, this makeup assignment, if you did very poorly on the first one, or if you feel like you didn't have a good chance of doing your best when you did the first one. Okay. Now we're actually going to talk about math, and boy, that took a long time. So it looks like we have 20 minutes to talk about math. So there's a few things that I want to talk about. I want to talk about restrictions on radical equations. and solving radical equations. Actually, what I'm going to say is methods. Methods for, and this should be lowercase, methods for solving radical equations. So those are the two things I'd like to talk about. We have 20 minutes. Sometimes I get carried away with housekeeping. Sometimes I end up just blabbering about these housekeeping items, and I take the whole class talking about non-mathematical related topics. Anyway, restrictions on radical equations. So these are methods for solving radical, let me start again. We're going to talk about 1, restrictions on radical equations, and 2, we're going to look at methods for solving radical equations. Okay, so restrictions, what does that mean? So let's talk about the first one. Recall, the square root of x is such that x must be greater than or equal, it could still be equal to 0, right? Otherwise, the square root of x is not a real number, i.e. The square root of x would be a complex number, okay? In fact, the square root of x is always a complex number, but not all complex numbers are real numbers. Some of them are real numbers, some of them aren't. Kind of like how not all rational numbers are integers, but all integers are rational numbers. Anyways, so recall that the square root of x is such that x must be positive. Otherwise, it would not be real. So, and right now, everything that we're dealing with is we're dealing solely with real numbers. We're not dealing with complex numbers. So, let's take a look at certain situations. So, e.g., let's do an example. What are the restrictions? What are the restrictions for this equation, the square root of 2x minus 3 equals x minus 3. Okay, so let's say that we're given this equation. And we're asked, what are the restrictions on it? So what that means is when we're going to look at the radicand, and this radicand has to be greater than 0, or equal to 0. I should say greater than or equal to 0. So what does that look like? So the restrictions are such that 2x minus 3 is greater than or equal to 0. Okay, so let's fiddle around with that. So what are the restrictions on x? Well, this works a lot like an equation. So we're basically going to solve for x. That said, there may be a few rules we need to cover about solving for inequalities. So here we'll do 2x is greater than or equal to 3. And we'll divide both sides by positive 2. And we'll get x is greater than 3 over 2. So that is the restriction on x. So if x is less than 3 over 2, we have a problem. It's a lot like non-permissible values. You could think of any value that's less, or any value of x less than 3 over 2, you could think of that as a non-permissible value. Okay, let's try another example. Okay, so find the determine the restriction on this equation here. So I've got the square root of 3x plus 4 minus the square root of 2x minus 4, all equal to 2. Okay. So here we have two radicals, and we have to consider both of them. So this needs to be greater than or equal to 0, and this needs to be greater than or equal to 0. Okay. So let's start off with the first one. So I'm gonna call this radical 1, and this one's radical 2. So with radical 1, I have 3x plus 4 has to be greater than or equal to 0. So I'll subtract 4 from both sides, and I'll get 3x must be greater than or equal to negative 4. And I finally get x is greater than or equal to negative 4/3. Great. So that's the first one. And the second one, oops, that's also a 1. The second one is 2x minus 4 is greater than or equal to 0, and I'll quickly solve that one. I've got 2x is greater than or equal to positive 4, and therefore x must be greater than or equal to 2. Fantastic. Well, how do we deal with both of these inequalities? Well, let's think about this. So both of these need to be satisfied. Okay, both of these need to be satisfied. So both need to be satisfied. Okay. So let's think about some just random values and see if they work, or if we're going to be breaking any rules. So let's try x equals negative 2. Let's try x. Actually, no. Let's try. Yeah, no. We're gonna do x equals negative 2. Okay. So let's see here. In this case, is negative 2 greater than or equal to negative 4/3? Does not look like it, right? Because negative 4/3, that is like, let's say that is negative 1.3 repeating. Okay, so we convert that to a decimal. It's negative 1. So negative 2 is definitely not greater than negative 1.3 repeating. And let me make that 3 look a little bit better. There we go. So it definitely does not satisfy that. Does it satisfy the next one? Well, is negative 2 greater than or equal to 2? No, it is not. It is absolutely not. So negative 2 is like a non-permissible value. That does not work. So you might realize that after I check this first one, I'm pretty much done, right? Because it does have to satisfy both of these. It does have to satisfy both of these. So what are we going to do then? So let's try another number. Let's say let's try x equals 1. Let's try x equals 1. Okay. So we're going to just try. Let's see if x equals 1. Let's see if this satisfies both of these inequalities. So let's try this first one. Okay, so x is 1 greater than or equal to negative 4/3. Does that work? Yeah, it works. Yeah, this one, it is greater than negative 4/3. So it does this would give you no problem in this radical, right? We would have 3 times 1 plus 4. We'd have the square root of 7, and we'd be laughing. No problem with the square root of 7. No issues. What about in here? Let's try the second one. Well, the restrictions on that one are that you'd have to have 1. Is 1 greater than or equal to 2? No, it is not. No, it is not. So we would have a problem in here, because here we would have, well, I'd have 2 times 1, which is 2. So we'd have 2 minus 4. We have the square root of negative 2. That's no good. So let's see if we can kind of simplify this a little bit. It seems as though one of these is more picky about numbers than the other, right? Like this first one here. Here, now I'll use my mouse. So this first one here, this one, like we're talking about, it's like x has to be greater than some negative number, right? Pretty easy to be bigger than a negative number. Any positive number will do just fine. But remember that both of these have to be satisfied. So, so this one here, x has to be greater than 2. So not all positive numbers work, actually. So it looks like this second inequality is the pickier of the inequalities. Like, think of them as people who eat food. You know, have you ever have a friend who's like really picky about food, and it's like, okay, well, like, what restaurant can we possibly go? Oh, and can you go? Yes, I will. Like, what kind of food can you possibly eat? Well, this second one here, this is definitely the more picky of the two. So really, this is the only inequality that matters, and I'll show you why graphically. So this first one here, x has to be greater than -4/3. Okay, so here's my number line, and here's 0. I'm going to say that -4/3 is right over here. So this is -4/3, and then the other one is 2. So I'm going to say that like this is 2. Okay, positive 2. So the numbers that we have to choose from, they could be -4/3 or greater. Any of these numbers satisfy that first one. However, we have to have both of these satisfied. So it also has to be greater than or equal to 2. So because both of these need to be satisfied, this area right here, this area right here is kind of like this sort of zone where you satisfy the first inequality, but you don't satisfy the second inequality. So this inequality here, this one where it's greater than 2, that is like the sole inequality that matters. I mean sole as in like single. So it's kind of like when you have a picky friend, you can only eat at the places that your picky friend can eat, right? Even though you're more than happy to try these kind of wacky restaurants and try interesting food like the stomach of a cow or something. Maybe you want to eat something really exotic, but your friend only ever wants to eat French fries. That means that you can only ever eat at the places that your picky friend can eat. So that's our restriction. So the actual restriction on both of these, so the restriction is that x has to be greater than or equal to 2. That's the only restriction that is meaningful. Okay, so that's restrictions. I'm gonna leave it there. I don't think we have quite enough time for solving radical equations. We'll get to that tomorrow. In the meantime, it looks like there's been a request to go over question 8K from the sheet from yesterday. So let me pull up the sheet. Oh, and by the way, I posted the solutions. The solutions are just on that PDF. So I just updated the PDF. It's the same file. So if you go back to the website, you can actually just now open that same document. So if you like downloaded it, I would download it again a second time because the solutions are on the last page now. So question 8K. 4, 5, 6, 7, 8K. Okay, so we're going to simplify. Okay, number 8K. We're going to simplify. Okay, we've got the square root of x squared plus 2x plus 1, x squared plus 2x plus 1, and x squared minus 2x plus 1, x squared minus 2x plus 1. Okay. And let me just make that a nice straight line. Okay, so this is what we're going to simplify, and I think this will take about 5 minutes, so this will take us right to the end of class. Okay, so the first thing that I want to do is I want to factor these. That's the thing that my brain is going, okay, yeah, if I can factor these, okay, we'll talk about absolute values as well. Okay, so if I can factor both of these, then I'll be golden. So I know that x squared plus 2x plus 1, that's equal to x plus 1 times x plus 1, and x squared plus, or minus 2x plus 1 is equal to x minus 1 times x minus 1. Oh, and look at that. This is x plus 1 squared, and this is x minus 1 squared. So let's simplify this a little bit more. This is going to be x plus 1 squared times x minus 1 squared. Okay, and this is going to give me, well, I'll just kind of split up the radicals. So I've got x plus 1 squared like that times x minus 1 squared like that. Okay. So, and this is a perfect example where we're going to have to use absolute values. So keep in mind that, like, there's really no restriction on x here, right? So keep in mind, well, like, we're not allowed to take square roots of negative values. That's something that's just not allowed. Just 1 second here. Yeah, we're not allowed to take square roots of negative values, right? Like, I cannot take the square root of negative 3. That's not allowed. But I could take the square root of negative 3 squared. What would I get? Well, the square root of negative 3 squared is going to be the square root of 9, which is positive 3, right? So, we have to keep in mind, like if I wanted to say, like, the square root of x squared, it's not always just equal to x, right? Because if x was, let's say, negative 3, then we would have, well, the square root of negative 3 squared is that equal to negative 3? No, it's not. It's equal to positive 3. Or in other words, it's equal to the absolute value of negative 3, which is positive 3. Okay, and same with that one here. So the square root of x squared is the absolute value of x, because maybe x is negative, right? We don't know that. It's unclear. So in that vein, I've got the square root of x plus 1 squared. That is the absolute value of x plus 1, right? And similarly, the square root of x minus 1 squared is going to be the absolute value of x minus 1. Okay, so, like, let's kind of investigate this a little bit further, because we still have a couple minutes left. So, like, what if x was equal to negative, let's say negative 10. Okay, let's take a look, and let's just focus on this portion here, just to make the numbers nice and easy. So let's say that x was negative 10, then we would have the square root of negative 10 plus 1. Oh yeah, negative 10 plus 1 squared. We would take the square root of it. Well, let's see what that's equal to. So negative 10 plus 1 is negative 9. So we would have the square root of negative 9 squared. And negative 9 times negative 9 is positive 9. Or sorry, positive 81. So this is the square root of 81, which is equal to positive 9, right? But x was equal to negative 10. How could we write this in terms of x? Well, this is the absolute value of negative 10 plus 1, right? Because negative 10 plus 1 is negative 9. So this is the absolute value of negative 9, which is positive 9, okay? So because x can be either positive or negative, yes, x can be anything, right? So if x was like a very negative number, like negative 1,000 or something, we could still take the square root of it because we're squaring it. We're going to get a positive number because of this exponent of 2. Right? That exponent of 2 takes a negative number and makes it positive, and then you can take the square root of it because you're taking the square root of a positive number. Now, your answer is going to be positive, even though x could be negative. And if you're writing it in terms of x, you have to say something about the fact that your x could be negative, right? Because in this case here, like this 9 has nothing to do with negative 10, right? Negative 10 is very different than positive 9, but over here we can turn it into positive by taking the absolute value. So that's what the absolute values are for. So I hope that makes a little bit of sense. If you struggled with this question, might I suggest that you try, so if x is either negative or positive, exactly, the answer will always be positive, because the whole idea is that this exponent of 2 here, this exponent of 2 is going to make everything positive, right? It doesn't matter what x plus 1 is. X plus 1 could be like negative 1,000,000, right? This could be like negative 999. But when you square it, it's going to be positive, because when you square numbers, they become positive, because a negative times a negative is positive. And then, once it's positive, you can take the square root, because you're allowed to take the square root of negative numbers. You're allowed to take the square root of positive numbers. Once you've done that, your answer is going to be positive, even though x was negative, right? So that's where the absolute value comes in. Do I have to simplify this further? I do not think so. If you wanted to, you could, and this isn't really a result that, no, this is fine. Just leave it at that. That's fully simplified. Fully simplified. Okay, I think that's all I wanted to say today. So tomorrow we're going to go over, oh yeah, I was going to make a suggestion for a similar question. Give me 2 seconds. So that was 8K. I would try, if you struggled with this, try 8I and J. Okay, so try those two and see if those make any more sense, and then try 8K one more time. Okay. So yeah, that's pretty much all for today. I'm gonna sign out, and so yeah, keep your eye out for that that feedback form that I'm gonna post. Don't bother looking at it tonight. Just look tomorrow. But if you do want that extra assignment, the makeup assignment, then start that now, because it's due on Wednesday at midnight. So or like at 11:59. So anyway, take care, and I'll talk to you guys tomorrow. Bye bye.